Hi, and welcome to the first episode of our series, The Art of Architecting Multi-Site Kubernetes. So we see a lot of people actually starting to build out Kubernetes clusters and start using those to run workloads. And as that matures, you can see more and more business critical stuff come into Kubernetes. So the question then becomes, how do we architect Kubernetes in a multi-site way? So especially when you add persistent storage into the mix, this can be a very daunting and difficult thing to architect in the correct way, right? There's many ways of doing it wrong. There's only very few ways of doing it right. So in this series, I will try to explain how you can actually architect it the right way from a storage perspective and also from a Kubernetes perspective. So starting off with Kubernetes is relatively easy, right? You basically build a cluster. Okay, so there we have a cluster. Okay, so now we have Kubernetes cluster 1, right? That can be vanilla Kubernetes, it can be OpenShift, it can be SUSE Rancher based, or RKE2 or K3S, or you name it, right? It can be anything. So any standard Kubernetes cluster will have 3 worker nodes, or a number of worker nodes actually, and 3 control plane nodes. So let's start off with the control plane nodes, right? So these nodes are there to actually make sure that we can control or orchestrate the containers that we're running in the cluster. So here I have these 3 control plane nodes, and then I have a number of worker nodes. So this is maybe worker 1, worker 2, and then we have worker 3, right? So this is a very basic standard setup. For example, if you deploy like an OpenShift environment, by default, it will give you as a starting point, it will give you exactly this, right? 3 control plane nodes, 3 worker nodes. The worker nodes will run the containers. The control plane nodes will make sure that they orchestrate the worker nodes and the running containers on it in a proper way. So this is all well and good, but like I said, right, things running on these clusters are becoming more and more business critical. So this Kubernetes cluster is probably sitting in a data center somewhere, right? Data center 1, maybe sitting in a public cloud, but even then it's still sitting in one single data center. So the question then becomes, how do I make it resilient to failure of this data center, right? What if I wanted to run workloads or actually have them survive in data center 2? Well, a very common solution to the problem is just create another cluster. So I can take another cluster right here. We'll call that Kubernetes cluster 2. And of course, this 2 will have these 3 own control plane nodes, C3, and then it will have worker nodes. I'll just give it 2 worker nodes, right? So in this case, we are now running separate Kubernetes clusters in each data center. So this is actually the way that lots of vendors actually prefer the solution, right? So when you talk to Red Hat for an OpenShift environment or through Rancher, they'll usually say Kubernetes is meant to run in a single location. There are ways of getting out of it, but this is the most painless problem to solve, if you will, the most painless architecture to have. So what you have here is you can run workloads on data center 1, you can run them on data center 2. Now, in a pure cloud native environment, you would always design all of your microservice designs saying that, well, you should always have multiple instances of a service. And if you're able to have some of the services run on the left data center and other instances of the same service running on the right data center, you're golden, right? So let's say that you run a container here. So this is container 1, and here I have container 2. So these are the same service. They're different instances from the same service. All I need to do now is basically have a global load balancer on top of here, and I could go out onto the internet, right? The global load balancer will load balance between the instances, between the data centers. If I lost a data center, I would lose half of my service instances, but I wouldn't lose a single service. So this Kubernetes could detect that these instances running here get really busy, expand to get more services running, right, more instances running, and basically recover from the problem. And of course, when this comes back, you can rebalance, and global load balancer will make sure that it stays in control and everything is fine. So there is one complexity to this. So right now I have a developer here, and the developer, you can see he's very happy because he just got a second data center to access. This developer probably uses, well, in a pure cloud native / DevOps style, he would definitely deploy anything through CI/CD pipelining. So he would just have his pipeline deploy a container here and simultaneously deploy the container there, keeping those two environments in sync. Then it would automatically talk to the global load balancer in order to make sure that it actually balanced properly and everything would be happy. So this is a very solid way of doing multi-site Kubernetes. The problem is that this is a perfect world. This is a perfect cloud native world. It's not always like that. And because of that, lots of people get tempted into not severing the environments, but actually stretching. So what does that look like? So if I put this to the side, go back to data center 1 and 2, lots of people tend to want to go here. They're going to say, oh, so now I'm just going to take one big Kubernetes cluster and I'm going to stretch that across the two sites. So now I have one single cluster to care for, 2 data centers, and I can use Kubernetes and labels and all kinds of interesting things to make sure that the workloads I provide to this single cluster either land on 1 or 2. So for worker nodes, this is a really simple solution, because where do you place the worker nodes? Well, I'm going to place some worker nodes in data center 1, and other worker nodes are going to be placed in data center 2, right? So right now I can run containers here, I can run containers there, all is good. Now for the control plane nodes. So you will always see that control plane nodes are an odd number of nodes. You can do 1, but that's considered like a dev test environment. For anything production, you're going to run 3 or 5, usually 3, you can do 5, but it's all about the majority of nodes, right? You always need to have a majority of nodes in order to decide which site will survive, which of these 2 data centers will remain active and which will go on standby. So majority of nodes. Where do we put the control plane nodes? Well, let's say I can put one here, control plane node 1. Why don't I put the other one here? Control node 2. Where do I put control node number 3? Well, lots of customers do this. Some even don't pin those, right? So you could potentially have all 3 control plane nodes running in one single data center. But let's say you did pin them and it looks like this. This is all well and good until something dramatic happens. So let's say that something dramatic is happening and we're actually going to lose this data center. So this data center is now gone. So as this data center is gone, I've lost 2 of my control plane nodes. Only 1 remains. That's not a majority of nodes. So as a result, the cluster will go down. Yeah, you have unavailability. Even if you solve the problem. So let's say that, oh, we solved the problem and now data center 2 is back up and running. These 2 control plane nodes will start. They were cut off at the exact same time. They will start at the exact same time. Chances are they cannot figure out who should be in the lead. When that happens, the cluster stays down. And to quote OpenShift people literally, you may have to restore etcd at this point in order to get the cluster up and running again. Of course, that isn't very nice. So if you decide to stretch across data centers, what is the smart thing to do? Well, the smartest thing to do is to get rid of this control plane node here, but introduce a 3rd data center. Let's not do that in red. So take the 3rd data center, or a 3rd data center, deploy some infrastructure there, and run at least control plane node number 3 here. So now I have got a control plane node in all of these data centers. Actually, this should be stretched, right? So I'm stretching across 3 data centers now. 1 control plane node sits in each data center. I can lose any of the 3 data centers at any given time and still have 2 control plane nodes left, which means I will have a majority of nodes, which means the cluster will always survive. And when the 3rd one comes back, it just reprotects, it resyncs, because these, if that one failed, these 2 will be stay in sync and they will stay functioning, and they'll just update the 3rd one when it comes back on. It will always work. You don't need to restore etcd. It just works. So as you go into this 3 data center setup, you can either have this as a really small instance where just control plane nodes are running, or you could decide to run worker nodes here as well, right? Worker node number 5, in which case you could run workloads from all 3 data centers. So this is basically the difference between stretch or sever, right? Are you going to stretch your Kubernetes across 2 sites, or are you going to sever them and build separate Kubernetes clusters? So this is complex enough as it is. Up next, we will be inserting this thing called persistent storage. So how do you bring persistent storage into this world, right? How do you make sure that things get replicated across? How do you make sure it works when you lose a data center? So that will be part 2 of the series. I hope you enjoyed this one, and stay tuned for the next one. Bye-bye.